On October 19, 2017, something happened that changed how we think about our place in the universe, but almost nobody noticed. On that ordinary autumn day, a telescope in the Hawaii was doing what it does every night, scanning the sky, watching for asteroids that might threaten Earth, routine work, mundane work, the kind of work that goes on without fanfare or recognition until it saw something it had never seen before. A moving object, fast, very fast, but this wasn't another asteroid in our solar system, following the rules we had known for centuries. This object was different, and it was already leaving. What happened next would unleash a storm of scientific debates, conspiracy theories, and a question humanity still cannot answer. Where did it come from? Let's go back to the source. The Pan-STARRS telescope sits atop Haleakala on the island of Maui. It's one of the most sophisticated automated asteroid detection system ever built. Every night, it scans about 3,500 square degrees of sky. That's roughly 1,500 times the width of the moon as seen from Earth. Its job is simple: find dangerous rocks before they find us. On that October night, the algorithm detected something unusual, a point of light moving against the stars, fast. The computer flagged it as a near-Earth object and sent an alert to the Minor Planet Center, the international organization that catalogs these things. Scientists examine it, and here's where it gets interesting. The object had an orbit that made no sense. Every asteroid, every comet, every piece of debris in our solar system follows the rules of gravity. Their orbits are either elliptical, closing loops around the sun, or hyperbolic, meaning they will eventually escape the sun's pull. But both types have a specific relationship. They bend around massive objects. The math is brutal and absolute. This one, it was bent the wrong way. When the numbers were run, the object wasn't orbiting the sun at all. It was passing through the solar system, like a visitor passing through a room, arriving from beyond, and leaving forever. Its velocity was so high, over 25 kilometers per second, that the sun's gravity, powerful as it is, could barely slow it down. This didn't happen, not for objects originating from within our solar system. You don't just pass through like that. The scientific community understood what they were looking at almost immediately. This was the first known interstellar object, the first visitor from another solar system. They named it 1I/2017 U1. Later it would be renamed Oumuamua, Hawaiian for a messenger from afar arriving first, and within weeks it became the most mysterious object in science. But here's what happened next that made everyone lean forward in their chairs. When you look at an asteroid through a telescope, it reflects sunlight. The amount of light it reflects tells you about its size, simple physics. But Oumuamua's light signature was unusual. As it tumbled through space, its brightness fluctuated wildly, not by a little, by a factor of 10, sometimes 5 to 10 times brighter, then darker again. What does that tell you? The object wasn't round. In 2018, an international team led by researchers from Queen's University analyzed the light data and concluded that Oumuamua wasn't a typical asteroid. It was radically elongated, roughly 10 times longer than it is wide. Picture this: an object as long as the Empire State Building is tall, but only about as wide as the city block. It tumbles end over end through the interstellar void, a spinning rod of unknown composition, hurtling at nearly 60,000 kilometers per hour. Now stop for a second and think about what you're imagining. That shape, that trajectory, that speed. You can see why some people started to wonder. The natural question erupted across the internet. What if this wasn't a natural at all? What if it was a probe, a sail, some kind of alien construct? By 2019, Harvard professor Loeb had begun seriously entertaining that possibility. In a series of papers, Loeb argued that the object's peculiar acceleration, which we will get to in a moment, couldn't be fully explained by conventional physics. He suggested that Oumuamua might be a light sail of extraterrestrial origin, deliberately sent from another star system to explore our cosmic neighborhood. It was controversial. Mainstream science pushed back hard, but Loeb didn't shy away. He published these ideas in peer-reviewed journals. He wrote about them publicly. He became the most visible scientist willing to say aloud what others whispered in private. What if we are not alone? What if they are here? Now, before we go further, you need to understand the scientific method. Hypothesis come before evidence, wonder come before conclusion. But in science, something extraordinary requires extraordinary evidence. And that's exactly where Oumuamua tests the very boundaries of what we know. Here's where the story gets really interesting. Starting in 2018, astronomers noticed something that shouldn't be there. Oumuamua wasn't just coasting through space on a predictable trajectory, it was accelerating. Let that sink in. The object was speeding up as it moved away from the sun, moving away, getting further, and yet somehow moving faster. The sun's gravity should have slowed down. That's the law. That's what gravity does. Every object leaving the sun should lose energy, should decelerate, should slow down. But Oumuamua was doing the opposite. When astronomer Marco Macaulay and his team at European Space Agency published their findings in 2020, they were careful with their language. They said the acceleration was non-gravitational. Those are the kinds of words scientists use when they are standing at the edge of known and looking into the dark. What could cause it? Several possibilities emerged, and here's where the debate became absolutely heated. The conventional explanation: outgassing. Most comets aren't solid rocks, they are actually dirty snowballs, mixtures of rock and ice. As they move closer to the sun, that ice sublimates. It turns directly from solid to gas, creating jets of material that shoot outward. Those jets, those rockets-like emission, can push the comet forward, accelerating it. It's like a spacecraft using its thrusters. The physics is straightforward. For decades, this would have been the default explanation. Comets do this all the time. But, and this is crucial, there was a problem. Telescope looked for evidence of outgassing from Oumuamua. Infrared telescopes, ultraviolet telescopes, equipment designed specifically to detect the heat signatures of evaporating material. They found nothing. No dust, no gas, no vapor. The object was utterly inert, a silent, dark, accelerating mystery. So scientists proposed alternatives. Maybe Oumuamua was a fragment of a much larger object, shedding dust due to impact collisions it experienced during its long journey through interstellar space. Could a trail of microscopic dust particles, invisible to our telescopes, produce enough thrust to explain the acceleration? Possibly, but the math was tight. The number had to be just right. The dust would have to be distributed precisely, behaving in a very specific ways. It felt contingent, possible but not elegant, not necessarily satisfying. Then came the hydrogen iceberg hypothesis. What if Oumuamua wasn't primarily rock? What if it was a chunk of frozen hydrogen ejected from space billions of years ago? When exposed to solar radiation, the surface of such an object would erode, producing exactly the kind of non-gravitational acceleration we observe. It was creative, it fit the data, but it required us to believe in something we had never seen before: an interstellar hydrogen iceberg, theoretically possible, observationally completely unverified. A similar proposal suggested nitrogen ice, frozen nitrogen, sublimating in sunlight, providing the thrust, again creative, again possible, but requiring us to accept something we had never directly confirmed. And here's what bothers scientists: when you have multiple explanations, all of which require assumptions we can't verify, you're at the edge of the knowable. You're making educated guesses about invisible things. It's science, yes, but it's science on the frontier. In 2020, Loeb, the Harvard astrophysicist who had earlier suggested the possibility of extraterrestrial origin, published a paper in the astrophysical journal Letters with colleague Samuel Bailey. The title was subtle, almost intentionally understated. Could solar radiation pressure explain Oumuamua's peculiar acceleration? But the implications were radical. They calculated the density required for Oumuamua to be accelerated by sunlight alone. If it were an extremely thin, extremely flat, artificially constructed object, a light sail, the kind of thing you might engineer deliberately if you wanted to explore interstellar space without a propulsion system, the numbers worked. That was the problem and also the answer. If Oumuamua were indeed a light sail, a structure with incredible high surface to mass ratio, then the pressure from sunlight alone could explain the acceleration, not outgassing, not invisible dust, just photons bouncing off an extraordinarily thin surface, pushing the object forward. It was audacious, it was scientifically rigorous, and it proposed something that violated most of what scientists had assumed about the object. The backlash was immediate and fierce. Within months, dozens of papers emerged offering alternative explanations. Scientists lined up to argue that the light sail hypothesis was premature, that it required too many assumptions, that it violated Occam's razor, the principle that the simplest explanation is usually correct. The ice hypothesis seemed more natural. Even if we had never seen a hydrogen iceberg, at least such thing could exist. But a light sail, a deliberately engineered object from another civilization, that required not just the existence of extraterrestrial life, but technologically advancement equal to or exceeding our own. It's important to note this wasn't unscientific. Loeb was following the scientific method. He was publishing in peer-reviewed journals. He was inviting criticism and responding to it. But he was also willing to go further than his colleagues, to ask questions they considered premature. And that made him famous and notorious, and to some critics reckless. The mainstream scientific consensus emerged. Oumuamua is probably a comet, probably ice, probably outgassing in ways we can't detect, probably natural, but probably is not certainty, and in the cosmos probably leaves room for doubt. By 2021, a new hypothesis emerged from the scientific community. It was elegant, it was creative, and it might actually be more plausible than any explanation before it. What if Oumuamua wasn't a solid object at all? What if it was a fractal dust bunny, an extremely loosely bound aggregate of dust particles, held together not by gravity or structural bonds, but by very weak electromagnetic interaction between dust grains? Picture something like a piece of space dust, so fluffy, so porous, so filled with empty space, that it mostly nothing, like holding a piece of foam and saying here's a rock. Such structures, if they exist in the interstellar medium, would have unusual properties. They could be extremely elongated, they could appear to accelerate as they tumbled and rotated. They could outgas without us detecting it, because the outgassing would be distributed across a massive surface area, barely detectable. It was the kind of hypothesis that made scientists nod and say yes, that could work. But here's the thing, we have never actually observed one of these interstellar dust bunnies. The hypothesis exists mathematically and theoretically. It fits the data we have, but we have no direct confirmation that such object actually exists out there. Do you see the pattern? Every explanation for Oumuamua requires us to believe in something we have never directly observed. Hydrogen iceberg, nitrogen iceberg, fractal dust bunnies, light sails of extraterrestrial origin. Pick your position. Every option asks us to accept something extraordinary. Let's ground ourselves in what we actually know rather than what we speculate. Oumuamua is real, its discovery is documented, its trajectory has been measured, it came from outside our solar system. This is certain, it has unusual proportions, this is confirmed, it exhibits non-gravitational acceleration, this is documented. Everything beyond that is informed speculation. In 2023, the European Southern Observatory published new observations. In 2024, NASA continued monitoring attempts. The latest papers on Oumuamua come from researchers trying to fit the data into existing framework, or sometimes expanding those frameworks to accommodate something genuinely unprecedented. Dr. Vahe Petrosyan from Stanford suggested the acceleration could be explained by radiation pressure on a surface covered in mirrors or ice. Dr. Amir Siraj at Princeton has proposed ways to detect future interstellar visitors, and Avi Loeb continues to develop the extraterrestrial hypothesis, arguing that humanity should remain open to possibilities we usually dismiss immediately. What's remarkable is that the scientific community, for all its skepticism about the alien hypothesis, hasn't landed on the definitive natural explanation either. It's not that the scientists are rejecting possibilities, it's that Oumuamua keep refusing to fit nearly into categories we have already created. Here's what Oumuamua has actually given us beyond all the scientific debate and theoretical frameworks. It's given us a question. We used to think about other worlds in our solar system. We used to look at Mars and wonder if something lived there. We sent rovers, we analyzed rocks, we looked for microbes. But Oumuamua represents something different. It represents the possibility of contact, not communication, not consciousness necessarily, but evidence that the universe is far more populated, far more active, far more connected than we assume. Every billion years or so, just by random motion of stars through the galaxies, objects will be ejected from the star system and sent wandering through interstellar space. Most will never hit anything. Most will drift in the dark forever, unknown and unobserved. Oumuamua, by pure chance, passed through our solar system at exactly the right time for our telescope to exist, to be sophisticated enough to catch it. How many others have we missed? How many entered our system before we had telescopes? How many will come after? And the deeper question, if Oumuamua was propelled by intelligent design, if it truly was a light sail, then somewhere out there, someone is waiting to see if we detected it. Someone is waiting for a response. We didn't even know we received a message until it was already leaving. Oumuamua is now too far away to photograph. Our telescope have lost it. It's beyond the reach of every instrument we possesses. By the time we have the technology to follow it, it will also be distant. That light from our solar system will barely reach it. It's gone. A visitor that will barely notice, carrying secrets we may never fully understand. In the years since its discovery, we have built better asteroid detection system. We are hunting for the next Oumuamua, the next interstellar visitor. We have learned to look at the sky differently, to expect the unexpected, but Oumuamua itself remains enigmatic. Was it a comet? Probably. Was it a hydrogen iceberg? Possibly. Was it fractional dust bunny? Maybe. Was it something we have never encountered before? Almost certainly. Was it artificial? Remotely possible? That's where the uncertainty lives, not in denial, but in acknowledgement that we genuinely don't know. And perhaps that's the most important thing Oumuamua gave us, not answers, but the courage to ask the question we were afraid to ask, not certainty, but the humility to admit how much we still don't understand about the universe and our place in it. The visitor came, the visitor left, but the question it raised will echo through the decades of research ahead. Somewhere out there, past the edge of our solar system, Oumuamua continues its journey through the dark, neither entirely mystery nor entirely solved, exactly as the universe likes it.